know you had though. I'm trying to do my answer.
That's how I feel.
I'm saying this thing.
We're about to talk about it. Okay. Thank you. Thank you. Thank you. All right. So let's talk about a couple of quick details on this. First off, I do want to point out it appears that everyone here was saying they're using factored form. Everybody use factored form? Okay. Why did we use factored form on this one?
Because we have 2 intercepts.
We have two what?
X-intercepts.
X-intercepts. Good. We want to notice we have two X-intercepts. What are those two X-intercepts?
1 comma 0.
1 comma 0 and
5 comma 0.
5 comma 0. Identify the points that you have, okay? So as soon as you say, hey, I have X-intercepts, remember, what is the first part of that X-intercept called, the X value?
The root.
The roots. So we're using what form? Let's put the iPads up. We can work on that stuff later. It's time for learning now. All right. Factored form, right? So once again, hey, Demarian, need headphones out. Once again, you cannot be successful in this unit if you do not know your equations. You got to know those equations. So what is the factored form that deals with roots?
F of x equals a parentheses x minus root 1 parentheses x minus root 2.
Anybody want to push back on or add on to or ask a question about that form?
That's correct.
That's correct. Feeling good about it. So as soon as I say, hey, I have x-intercepts, I have roots, I want to use that factored form there. And so, yes, sir.
I was going to say, like, were you going to say where we use numbers?
Okay, yeah, I was going to ask what would I do with that 1? What would I do with that 5?
The 1 and the 5, the 1 would go where the R1 is, and then the 5 would go with R2.
Okay, so those are my roots. F of x equals a times
X minus 1.
minus 1.
And then X minus 1.
Wouldn't it be 0 times x?
And that's one of the common mistakes. So remember, okay, the x and goes, an input of x has an output of f of x, right? The x value, or actually I'd even point this out. Is that an x value right here? It's a y value. The roots are taking the place of R1 and R2. Those zeros do not play into this. Remember, once you get this set up, you still need one more what? One more point. You need a whole other point. What's the other point we have, Brooks?
3, 6.
3, 6.
Negative.
Be careful, remember, it's to the right 3 and down 6. You need a second point, or another point, not always a second. In this case, a third point to finish writing that equation. Notice here, Lucian, how I have an x and a y. So I'm going to substitute 3 in for x, and negative 6 gets substituted in for
Y.
y, or f of x.
Yeah, the f.
Please note that is not a, right? And that's where, Jordan, you guys started on, and you had negative 6 almost there for a. Right? We want to make sure we remember it's not a. We've got to write out that function, that formula function from the beginning. So what's being substituted here for f of x?
Negative 6 equals
Negative 6 equals,
A
3 minus 1. And then 3 minus 5.
okay? So I want to pause here, okay? Micaiah, how's this shaking out for you? Because you asked a question earlier about what to do. How does this make sense? And please know we're on number 3, not on number 1. Yeah, I was like, that doesn't, may not look right from there. But do you understand how we have x-intercepts? So I'm using the factored form, and I substituted my roots in to get started. Okay? Do you understand that R1 and R2, those roots are the x values of the x-intercepts? Okay? So I just substituted R1 and R2 in. Right here, here's my x-intercepts. So there's R1, there's R2. R1 and R2, good with that? So, x minus 1. So, yeah, I just counted. 1, 2, 3, 4, 5. That's how we identify points. Yeah. The same way I got 3, negative 6. I went to the right, 1, 2, 3. To the right, so it's positive. Then I went down 1, 2, 3, 4, 5, 6. Just counting. Now I have an equation. Yes, sir.
And that 3 came from 3 negative 6.
Because if I have an input x of 3, I have an output f of x negative 6. That's it.
So what if you got more than, 3
Then you choose which ones you want. Yeah. And so I will point this out. All I have now is one unknown. I need to solve for a. And this is to help us practice the idea of solving. When I solve an equation, what's the first thing I should really do?
Was in the parentheses.
So what's inside the parentheses, so I'm what? Simplifying, right? It doesn't always have to be what's inside parentheses, but I do want to simplify first before I use inverses. What's 3 minus 1? 2. What's 3 minus 5?
Negative.
Okay? I always want to simplify first. Is there anything else I can simplify? Bless you.
2 times negative 2.
2 times negative 2, which is?
Negative 4.
So I have a times
Negative 4.
negative 4. Notice I am very intentional about putting that multiplication, otherwise you'll get messed up.
You use this reciprocal.
I am multiplying by negative 4, so now I need to divide by negative 4. So yes, I would use the reciprocal. Remember, it's understood to be divided by 1, so I multiply by 1. What's this fraction bar?
Divided by.
Divided by
Negative 4.
negative 4, right? I'm still dividing by negative 4 there. I'm going to ask an important question in a second, but I do want to pause and ask, what are your questions before I continue?
How did you get negative 4 divided by 1?
So any number is understood to be divided by 1. You don't always have to write it, but by writing this, it helps me recognize that reciprocal more easily. Any number, so like, because think about it, what is 5 divided by 1?
5.
That's 5. What is negative 17 divided by 1? So any number can be understood to be divided by 1, and it just helps me identify that reciprocal a little bit more easily. Does that answer that question?
Yes, sir.
Okay. What other questions do you have before we continue? Say again.
Can you spell reciprocal?
Reciprocal?
R-E-C-P.
There you go. Yes, sir. So when you mean on the grid, like at the intersection of the grid, and it has to be on the curve. Is that what you're talking about? Notice this is not a line. This is a curve, right? Yes, it has to be on the curve because like, is this point a part of that quadratic function? So it's got to be on the curve. And then I don't want this point because do I know exactly what those coordinates are? So I want a point that is on the intersection of the grid. It needs to be on the curve and it needs to be on the grid to make it easy to identify what the point exactly is. Okay? Now, Mikhail, do you have a question up to this point? We're solving for A?
How you get 3? Like, where did you get it?
1, 2, 3 to the right. Down 1, 2, 3, 4, 5, 6. So I went to the right 3 and down 6 to get to this point. Just counting.
How is that 4 negative?
What is a 2 times a negative 2? Right? We've got to remember, what's the only operation we don't have to write in between numbers? Multiplication. It's understood to be multiplication, okay? All right. Now, from a solving perspective, and this is important, why did I multiply by 1 divided by negative 4 on both sides of the equation? Scott?
Properties of above.
Okay? And so what is that? So what we do to one side of the equation, we do to the other, right? But why is that important? Make it what? Close. Balanced. It's going to keep it true. But remember, I'm changing this equation, but do I want to change what it means? No. So I want equations that are equivalent, right? Those properties of equality, I've changed my equation, but have I changed its meaning? Nope. So I've kept my equations equivalent. What is 1 divided by negative 4 times negative 6? 3 divided by 2, or 3 halves. Okay. Alright, I'm done, right?
No.
Oh, what do I need to do?
Plug in.
Substitute A back in, right here. Is that right? Why not? That is correct. Let me ask you an important question. Is this the equation of a function? I need to substitute into the function equation. Notice, this would just be a statement that's true. That was the whole point of solving. I need a function. Okay. Everyone use factored form. First off, what are your questions up to this point in factored form? Good. Kayla, you good? You being for real, for real?
Yes.
You sure? You sure? Okay. But I gotta ask you an important question. We all use factored form. Could I have used vertex form? Why? Do I have the vertex? This is a key thing where you need to notice, can you use factored form? Sure. But could you use vertex form? Yes. If you have a vertex, can you use vertex form? If you have x-intercepts, can you use factored form? So if you have both, which one do you use? Either one, whichever makes you feel comfy, I don't care. Okay? If you have both a vertex and a factors, then, or x-intercepts, then you can use either one. Now, here's what I will point out. You don't need to write this down, I want us to just follow along. I'm going to focus on that vertex right now. So what form am I using? Vertex form. So I'm going to write out my equation. What is vertex form? F of x equals A squared plus K. And this point is my H comma K. So I've got my vertex form now. How many more points do I always need to find A? I only need one more. What are the options? I still have 1 comma 0 and 5 comma 0. I have 2 extra points. Does it matter which one I use? No. So, sorry, this is answering the question you had earlier. First off, notice I can use factored form or vertex form. But you see how I have 2 points here? It doesn't matter which one you use. You just have to pick one of them. Show of hands if we want 5 comma 0. Okay, show me if you want 1 comma 0. Got 2 people who voted for it. Let's go with 1 comma 0. So, what's being substituted in for x? 1. What's being substituted in for f of x? 0. So 0 is equal to a times 1 minus 3 squared minus 6. Trying to solve an equation. I've got one unknown, so what's the first thing I want to do? Simplify. What's 1 minus 3? Negative 2. Negative 2 squared. Negative 4. First off, don't be scared of calculators. I encourage them. Second off, when we square something, what does that actually mean? Times itself. So that's negative 2 times negative 2, which is a positive 4, right? We want a positive 4 here. So a times 4 minus 6. I've simplified everything I can. Those are being multiplied, that's being subtracted, I can't do anything there. So now that I have simplified, I'm going to use my inverses with properties of equality. You've got to remember that every time. So, and this is going to help you with part of today. First off, look at A, because that's what I'm solving for. What's happening to A first? It's being multiplied by 4. After multiplication by 4, we're subtracting 6. The last operation being done is the first one that I want to undo.
Yeah.
Right? So it's subtracting 6, so I'm going to add 6, add 6. 6 is equal to A times 4. Caitlin, what operation do I want to undo now to solve for A? Huh? I'm looking here. What do I want to undo? Remember, I want to solve for A, huh?
Multiplication?
I want to undo the multiplication, so what am I going to do? Divide by 4. Or remember, we can use the reciprocal, right? 1 divided by 4. And what is a quarter of 6? If I put 1/4 times 6 in my calculator, what do I get? 3 divided by... Hey, is that the same A we got over there?
Yeah.
Yeah. Uh-huh. The same A. I'm going to use this function the function format. So f of x equals 3/2 times x minus 3 squared minus 6. Could these be the same function, just in different formats?
No telling.
No telling.
No telling.
Well, let's look at it in just a second. Yes, ma'am. Where? Oh, this 0 right here. So notice I'm using this point where x is 1 and y is 0. So where there's a f of x, my output, I substitute 0 in. Where there was an x, I substitute 1 in. Okay? So that's why I got a 0 there, because I'm using the point 1 comma 0. This is my input, x. This is my output, f of x. Okay? So, we do get a 3/2 for both of these. Let's check this really quickly. Let's go to documents. You don't need to do this, but I'm going to do it for you. I'm going to create a graphs page. Alright, so what was it? 3/2 times x minus 3 squared minus 6. What should I see up here if that factored form and that vertex form are equivalent?
The same parabola.
I should see the same exact parabola, right? 3 divided by 2 times x minus 1 times x minus 5. So do they both work?
Yeah.
Yep. So, Tristan, it's not who knows, I can check it,
Yes, sir.
right? Notice if I look at this graph, it has 3 comma negative 6 as the vertex. It has 1 comma 0 and 5 comma 0 as the x-intercepts. So, my point is, sorry to answer your question, 100% you can use whichever extra point you want. Second off, if I have a vertex and I don't have x-intercepts, I have to use what form? Vertex form. If I have x-intercepts and I can't clearly tell what my vertex is, I need to use factored form. But if I have both of them, does it matter which one? No. It's pick them, your choice. And I will say this, usually on a test, I like to give you options. More than likely, you'll be able to choose which one you want. But you need to justify why you're using the form you use. Alright. Agenda. Oh yeah, I want to send out a quick poll question to you to give you some options. Tomorrow, the studying is going to be based on what you want to study. So, I'm sending out a poll question. There are several different things that are on the midterm. You identify the 2 that you want to study tomorrow, and I will put you into groups based on what 2 you want to study. Kristen, do you want to mark which 2 you want to study? It's on the calculator. If you're having trouble with the calculator, let me know.
Ooh. Wait. Oh.
Let him answer the questions. Yes, how many can you pick?
5.
2. Pick 2. And there's more than 5 options.
3.
If you pick more than 2, then I will just randomly put you into a group. Pick 2.
Just do all.
Hold on. Hey, y'all will have 2 days, and I'll let you pick 2 more for the next day. And if your group gets done early, then we will have more time. But pick 2 for now. I will remind you, because I know some of us got very angry that I did not give a traditional study guide yesterday, but what is your best study guide for your midterm?
No.
Their pre-assessment, and the notes definitely should tell you a lot, but the unit test that you got back, guys, your midterm, 3/4 of it looks very, very, very similar to your unit test, because I want to see if you have learned from your mistakes. I want to see if you have grown in your understanding, and I will account for that in your grade. So this midterm could make a huge difference in your grade if you show me greater understanding on the unit test and that. Yes, Kennedy.
What if I'm like at an 89? Can you bump it up?
No, I can't bump it up, but if you show me greater mastery on the test, then I will account for that in your grade. So, show me that you have learned, and I will honor your learning. That's the focus of the class. That's the point of the class, is to learn. And it does take time. I understand that. Anybody need me to hold off on stopping the poll question? Going once, going twice, sold. All right. Now, bless you. Bless you. Remember, when you are studying, okay? When you are studying, and I look here at, I don't know, the first question here. And I'm like, man, I don't know how to do that. One, there are understanding checks that have solutions. I will post my solutions to this on Schoology so that you can see it and see what I wrote. But also think through, what do I notice? What can I use to get started? If I'm just asking you, hey, what type of function is it? Well, if it's a graph, what tells you the type of function based on the graph?
You say if it's a graph?
If you have a graph and I ask you what type of function, it's not always a line. If it's a line, it tells me it's linear. If it looks like this, that's an exponential curve. Remember, a parabola is quadratic, right? So the shape of your graph tells you what type of function it is. If I was then to ask you, hey, what to write the equation of this function, okay, I know from the shape that it's an exponential function. What should you immediately do next if you know it's an exponential function and you're trying to write the equation? Write the formula out, right? Write the equation of an exponential function. So my point is, your Venn diagram should have a summary of the graph shape. It should have a summary of the rate of change we see in tables, and it should have your equations. Those are the foundations. And then you also want to identify where do these things overlap and where do they differ. Because there's actually two types of functions that have repeated addition in them. What are the two types of functions that have repeated addition? Linear and quadratic. Which is why you can't tell me in a linear that's just repeated addition, what type of additive rate of change does a linear function have? Constant additive rate of change. Whereas a quadratic function has what type of additive rate of change? Linear additive. And give examples with tables. The more that you're able to fill out one of those Venn diagrams, the more successful you will be. Okay? So that is something to be aware of. Tomorrow we will be using our unit test and an extra little bit of information or practice problems that I'll create to help you prepare for the midterm. Okay? Quick show of hands, does anyone want a blank copy of the unit test? Okay, so.
For a grade?
Well, Nathan, you're taking the midterm tomorrow. I can print one out for you if you want today, but no, it's not for a grade, okay? It's just to have it as a separate thing. Well, I mean, you have the unit test. The blank one would be so that you can work it out on that sheet without stuff already written on there.
Well, it's,
Huh? It's chalk. I was rubbing chalk off and I rubbed my
I was just gonna say, I didn't need to, my test was gonna be good stuff.
Right, but we're not, remember, we're using our unit test tomorrow in class to practice problems and analyze and understand.
Wait, do we take it on Friday or Thursday?
Y'all take it on Friday. That's why you have tomorrow and Thursday to prepare. Okay, so do not forget, studying is not just a matter of doing, it's first understanding the concepts. What does it mean to be linear? What does it mean to be exponential? What does it mean to be quadratic? You also have got to study those 5 equations. We have to know the 5 equations. There's no excuses after 6-7 weeks of studying those equations that we do not know what a linear equation is, what an exponential equation is, and what the 3 quadratic equations are. We got to know them. Yes, sir?
How many questions are there?
25.
That's separate
Probably
pages?
25.
Huh?
Is it separate pages?
You're saying on
It is going to be the exact same format as what you have. So there will be a non-calculator portion, there will be a calculator portion, And there might be a short answer question as well.
So you mean only 25? So you're not gonna give us an extra page with another 25? You mean like only 25?
Between those pages, there are a total of 25 questions. Okay? 25 questions in 90 minutes. Alright. We need to practice factoring today. We did not get there yesterday. All we did was take notes, I believe, and we need to practice factoring.
I still don't understand.
Well, it's a good thing that we're going to practice it today.
Oh yeah, that's true.
Yep. So I do want to point out here, what format, so this is page 81, I believe, in the textbook. Okay. Yep, M1-80 in the textbook. What format we have? What do you say, Martavius? Vertex form. Each of these are a vertex form of a quadratic equation. M1-80. Each of these are a vertex form. So if you see the vertex form of a quadratic equation, how are you going to solve that equation? You have vertex form. So notice this is not the function. I'm not asking for the features of the function. I'm asking you to solve this equation. How are we going to do it?
Using vertex.
Use what?
Vertex.
So we were going to use properties of equality with inverses. So be careful. So Jordan, what you're probably thinking about is if I'm asking you to write the vertex form, right? But I'm not giving you a function. I have given you a quadratic equation with how many variables? 1. And that's a telltale sign. If it's a function, how many variables does it have? If it's a function, it has 2, because it needs an input and an output. My input is usually x, my output is either y or f of x. That's not a function, that's an equation. I'm going to ask you to solve for x. And so when I see this vertex form, I'm using inverses with properties of equality. And do not forget, the way we figure out what inverse to use is by reading the equation. Whatever the last operation is, that's the first one that I undo, right? When I look up here, can I get a volunteer to tell me what is the first thing happening to x? Skylar? Remember, raise your hand if you want to, right? X is being added by 3. What is happening after x is being added by 3? It's being squared. Remember, raise your hands. Sorry, shouldn't meant to say that. It's being squared. Is there anything else on the left-hand side? No. So the squaring was the last thing I said. So then what undoes a square? Square root. Okay, that's the last thing being done. That's what I'm going to undo. The square root, the square cancels. Can I get someone to volunteer and tell us what is on the left-hand side of this equation then? Marian. Remember, the whole point is that square root just cancels out the square. I'm left with x plus 3. Someone else for the right-hand side, Martavius. 11. We need a positive and a negative 11. Is that true? Well, remember, that's just a symbol to say positive and negative 11. You could write it out as x plus 3 equals a positive 11 and x plus 3 equals a negative 11. But as long as it's mathematically accurate, I'm good with you being lazy. Right? That's the same thing. X plus 3 equals a positive and negative 11. Okay? And so, Shatiri, I did see you raise your hand earlier, and that's my bad. Do you want to tell us what the next thing to do in solving this equation is? Subtract 3. What is 3 minus 3? 0. Notice the plus 3 is the last thing there. And now I have to read it as it is. Positive 11 minus 3. 8. X is equal to 8. Negative 11 minus 3.
Negative 4.
Thank you. There's my solution. So you got it.
Wait, I'm confused. How you got
11? Square root of 121. So, I will point this out, 2 things, and this will answer your question too, Kadarius. When I take a square root, what am I trying to find? What times itself equals 121? When I take the square root of 121, what I want to know is, what was squared to get 121?
2.
What was it?
2.
2 squared is equal to 11? 2 times? Sorry.
What was squared, dude?
Oh, well, which one?
But what was here that I squared, what did I multiply by itself to get 121? 11. Anything else?
Would you do the same thing for A?
Very similar, and I'll look at that in a second. But notice, Kadarius, because I'm squaring, negative 11 times negative 11 makes a positive 121, doesn't it? So I needed both a positive and a negative. So how many solutions do I need? And I'll remind you guys, how many roots does a quadratic function usually have? 2.
How you know when the question got 2 answers though?
If it's quadratic, oh, okay, so here's we haven't studied it yet. There's one time when there will be no solutions, and let me clarify, no real solutions. We're gonna talk about that after spring break. If you got to this point, do you know of anything that I could square and get negative 4? No. There is a number, it's called the imaginary number. We'll study it after spring break. But we don't know that one yet. Okay? Or, if I get x minus 3 squared equals 0, when I take the square root there, what's the square root of 0? 0. Can I do a positive or a negative 0? No, it's just 0. So this would be the one time when I get just one solution. If I take the square root of a number, it's always going to be a positive and a negative. Make sense? Okay. So if you just solve it, and you have a number on the right-hand side other than 0, you'll get 2 solutions. Okay, quickly, because Zari did ask this, but we do need to get to factoring. Zari, you asked if we do the same thing on A, right? Well, what's the first operation happening to x? It's being squared. After x is squared, it is subtracted by 9. So I'm going to add 9. That creates a 0. 36 equals x squared. Square root. What was squared to get 36? 6 and negative 6. So notice again, Kadarius, when I take the square root of a number like this, it's positive and negative. As long as it's not a 0, I'm going to get two answers there. Okay? Ireland, did I see your hand up?
How you got negative 14?
How, what?
Now, how you got negative 14?
So remember, positive 11 minus 3 is 8. What's negative 11 minus 3?
Oh, that's what.
Right. Does that make sense now? Okay. So I'm just reading that equation as it is. But here's the thing. That's only when we're solving quadratics in what format? Vertex form. What happens if it's in standard form? Can I use inverses? I cannot use inverses to solve the entire equation. That's what you need to remember. If it is in standard form, I cannot use inverses with properties of equality the whole time. But what we said instead is this. We're going to use that zero product property. If I am multiplying two things and their product is 0, what do I know about those factors? At least one of the factors has to be
0.
So either x minus 3 equals 0 or x minus 1 is equal to 0. Now, I want to show you some things I think is going to make the factoring more clear before you start to work at the vertical surfaces. Does anyone know what factoring is trying to undo? I mentioned this yesterday. Go for it.
I think the exponent.
It's not trying to undo an exponent. I'm trying to go, let me point this out. You don't want to. You want to use zero product property. What are you going to say? What? Talk to me in a second because we're not going to the restroom. Hold on.
Bad. It is a rumbling. Argentine. What kind of feeling?
Talk to me in a second. Right here with this, can I distribute?
Yes.
When we distribute, I'm going to take this x and multiply it by what? The entire x minus 1. Usually we just do x times x minus 1, but I do want to point this out. This is really x times x minus 1 right here. What am I going to do with this negative 3? Starts with a D. Ends with this distribute. Yeah, there we go. To x minus 1. minus 3 times x minus 1. Okay? Now I can do x times x, which is, remember that's multiplying.
X squared.
Okay. Remember, multiplication is repeated addition. I'm repeatedly multiplying, so I need an exponent, x squared. X times negative 1. Minus 1x. Negative 3 times x. Negative 3 times negative 1 is plus. Okay. What is negative x minus 3x? Guys, we got calculators. Negative 1 minus 3. Okay. Here's what I want you to see out of this. That's what I get when I distribute, right? What I'm trying to do here is go from standard form. You see how this is standard form? Yes? I'm trying to go from standard form to factored form. So that's what I started with, wasn't it? So literally, if I'm trying to go from standard form to factored form, aren't I just going to go backwards? That's what we're trying to do here. When I look here, the first thing is I need to split this middle term up into how many terms?
2.
2. The way that you know what 2 terms it is this. This is how to split bx into 2 terms. I'm trying to go backwards. So the first thing is I'm going to multiply my a by my c for the AC method. And then I'm going to use those factors of AC that add up to b. Negative 1 times negative 3, that multiplies to give me 3. And it adds to give me negative 4. So that's how I know what to split this middle term up into. Once I have those 2 terms, what do? I factor the GCF out, the greatest common factor. When I look right here, what factor, what thing is being multiplied that both of these terms have? Wait, they both have an x? And if I factor out an x, I divide out an x. If I divide out one of those 2 x's, I'm left with x. If I divide out that x, I'm left with, see how that's minus 1? So I'm factoring out the greatest common factor here. And I look at these 2. What do negative 3x and positive 3 have in common? What could I divide out of both of those terms? I can divide out a 3. Now, I actually divided out a negative 3, because what is negative 3 divided by negative 3? Positive 1x. What is that?
No, did I never start this? Yeah.
What page? Just put it on charger for now. The majority of what we're doing is on the calculator. We are on page M1-8. Okay. Right here, I want to remind you that when we have this formula or this format for a quadratic equation, what format is this?
Vertex. Oh.
Is this vertex? Hey guys. Okay. Talking's gotta stop. What format, because all 4 of these are in the same one. Which of the quadratic equations do we have here for the forms? They're vertex. What is a telltale sign that we have a vertex form? It's not just the parentheses, x minus h being squared. I'm talking about all of them. All of these have an x minus h. Now, technically this one's a little unusual, but it could be x minus 0 squared. So every single one of these can be seen as an x minus your h squared. It's a vertex form. What methods do we use to solve a quadratic in vertex form? Properties of equality with inverses. Thank you, Elise. Guys, we've talked about this days in a row now. We got to know this. If you have vertex form, you are going to use properties of equality with your inverses.
Every time you add that question,
I'm sorry, I have not heard you. Okay?
Good job, Jay Sean.
Now, I need y'all to remember though, the order to use our inverses and our properties of equality. Headphone out, Tristan. The easiest way is to read the equation. You don't just read it from left to right, you follow the order of operations. AJ, what is the first thing happening to this x? That's inside of parentheses, right? So it's x minus 1. Shakai, what's happening to x minus 1? What's happening? What's the next operation happening to that x minus 1? So, I mean, there is a square, so is a square the next operation that's happening to x minus 1? Yes? I mean, exponents do happen before multiplication, don't they? So, what's happening to x minus 1 squared then? Being multiplied by 3. Is there anything else on the right-hand side of that equation? So what's the last thing we just said there, Hannah? What did we say the last thing there is happening? Multiplying by? First step to undo. First step for inverse. So how am I going to undo that multiplication by 3? Divide by 3. And remember, I recommend that reciprocal, because how is this read? 1
Over 3. Divide by 3.
Divide by 3. That is my division by 3. Okay? What's a third of 48 then? 16. Equals 3's cancel, leave me with the exponent of 1. I have x minus 1 squared.
Divide.
Now what's my last operation being done?
Square.
The square. So what am I going to do?
Square root.
Square
root.
Wait, what?
X minus 1.
So x minus 1 is equal to?
16.
No, okay.
No,
Positive,
four.
positive.
Why is it a positive or negative? I feel like this is a detail that a lot of students miss.
Because you can multiply -4 times -4 to get positive.
When we take a square root, we're asking what was squared, right? What could I multiply by itself to get 16? 4 and -4. So how many numbers do I need here? 2. Okay. Now what is the last operation being done on the right hand side to that x? Subtract 1, so I add 1. So x equals, what is 4, a positive 4 plus 1? 5. What is a negative 4 plus 1?
-3 on trim.
You're good. But that's it. If I have the vertex form of a quadratic equation, I'm going to use what?
Do what?
If I have the quadratic, or if I have the vertex form of a quadratic equation, how am I going to solve it? Use inverses. With properties of equality. Say again, sir?
Oh, never mind.
Okay. So that is just a quick reminder, okay? If you have the vertex form, we're going to use inverses with properties of equality. But then we came across this situation where we had x squared minus 4x equals -3. Was that in vertex form? No, it's in standard form. And so I cannot solve a quadratic in what form? Standard. But what method did we already talk about that we can use other than standard? We use factored form if it's equal to 0. So the first step right there, we added 3 to both sides. And we got x squared minus 4x plus 3 is equal to 0. Now, I'm going to do a quick review in a second about the factoring process, but the factored form of this standard form is x minus 3 times x minus 1 is equal to 0. This is why we want to factor, right? We're going to go back through how to factor in a second, but this is why we want to factor. Because if I'm multiplying two things and the product is 0, I can use the 0 product property, which tells me that at least one of the factors has to be what?
0.
So I can now say x minus 3 equals 0, or x minus 1 is equal to, and that equation, or those equations, are really easy to solve.
Yep.
Okay? So, don't forget, the reason we're doing what we're doing is we cannot solve a quadratic in what form? Standard. But if I can get factored form, and it's equal to 0, I can use what property?
Zero product.
Zero product property. I want to go from standard form to factored form so that I can use that zero product property. That's the goal here. So what skill do we need to develop?
Using the zero product problem.
Well, that part's easy. I need to get from standard to factored form.
Alright, so change it.
So we need to practice doing that. We did that yesterday. Yikes.
That's what you get. You should have left it alone.
So, here are still the notes from yesterday that I'm going to leave on the board today. One thing I need you to notice, and we are about to get to the vertical surfaces, Bryson. Yes, this is always going to be our first step. We're not doing this yet, don't worry about it. We're focusing here on using the AC method to factor a quadratic equation. We are focusing on using the AC method to go from standard form to factored form. Okay. Now, I cannot remember if I showed y'all this in class yesterday, but this is why we are doing those 4 steps. I want you to see those 4 steps, or why we're doing those 4 steps really quickly. If I take x minus 1 times x minus 3, that's factored form, right? We go with that means factored. If I distribute x, isn't x being multiplied by x minus 3?
Yes.
So that is just x times x minus 3. I'm going to come back to that in a second. I'm also going to take negative 1 and distribute it to x minus 3. So minus 1 times x minus 3. Okay? If I'm distributing, so pause for a second. I'm about to tie this into the factoring process. I'm explaining why we factor the way we do. Okay? So if I distribute, this is what I get. Now, what is x times x? X squared. X times negative 3. Negative 3x. Negative 1 times x. And negative 1 times negative 3.
Positive 3.
Oh, yes.
Right? Now, right here, those are like terms. So I get x squared minus 4x plus 3. To go from factored form to standard form, I distributed and simplified, right?
Yeah.
But now I'm trying to go from standard form to factored form. So what's the first step to go backwards? I need to take that middle term and make it how many terms? 2. You see right here, these 2 steps, multiplying a times c, and then we use factors of a times c that add up to b. That is how we go from this standard form to right here.
Now you're trying to see what the roundabout do.
Well, remember, so a is an understood 1, right? So 1 times 3 is 3. I need factors of that 3 that added up to negative 4, which are negative 1 and... Remember, I need something that multiplies to give me a positive 3, and it needs to add to give me negative 4. So, negative 1x and negative 3x. That gets me through steps 2 and 3 right here. Multiply a times c, then use factors of a times c that add up to b to write bx as 2 terms. That's all I've done. Now, I need to go from these 4 terms to factoring out the GCF in these first 2. What do x squared and minus 3x, what factor do they have in common? Factors are things we multiply. They both have an x. X squared is literally x times x. So if I factor x out, what am I left with here? 1x. If I factor out this x from minus 3x, I'm left with minus 3. So all I did was I factored out those common factors. What do negative 1x and 3 have in common? Not much. They only have a negative 1. And I want a negative 1 instead of a positive 1 because when I factor out, I want the same binomial. But I factor out a negative 1 and I'm left with x. And I need y'all to hear me clearly on this. Factoring is a whole lot like dividing. Use your calculator if you need to. What is positive 3 divided by negative 1? Positive 3 divided by negative 1. Negative what?
3.
Negative 3. Oh, there it is. That's step 4 right here. That's it. Factor out the greatest common factor as the first two terms. Do the same with the last two. Then, when we look right here, what do this and this have in common? X.
Yeah, this is why.
They both have an x minus 3, don't they? So I can factor out my x minus 3. And when I factor out that x minus 3, I'm left with
X.
and there's my factor form.
For sure.
All factoring is doing is undoing that distribution process, following these 4 steps. Okay? So, hold on one second. Hold on one second, I'll take care of it in a second.
He said,
Yeah,
hold on one
What did I
second.
say, Jay Sean?
Oh.
I said, hold on one second, I will take care of it. But, I mean, he did, baby.
I was lost in the song.
Okay. So right here, we did x squared. Nope, y'all don't see that.
See what?
The thing that you don't see. Y'all, we did x squared plus 10x plus 24 yesterday, didn't we? Yes, you grabbed it. Did we do that one at the end of class yesterday? Thank you.
Yeah.
So we are going to now practice using the factoring by the AC method here with 1.4. So the question is now on your calculators because I started the poll. Let's get up to our vertical surfaces and let's get to work
Okay, guys.
on factoring these equations. P.S. Please don't put the calculators on these silver rails. Multiple students have been dropping them today. Come on, let's get up. Let's get
Man,
moving.
this kid, I swear to God.
What?
Why we always up here at the whiteboard? You ain't changed the groups up in a minute.
I'm sorry you feel this way. It was 2 days ago that I changed groups.
I'm talking about guilty, man.
I know
you talking about what we work at.
But when I change the groups, then you will get to work at new surfaces.
Gage, come here.
But group one's over here on the side whiteboard. Sorry. We need factors of A times C that add up to B. And all we're going to do with those factors, right? And we eventually got there. 3 and negative 5. Do those add up to the B of negative 2? Oh, yep. 100%. All I'm going to do is pull those factors, and those are going to be my coefficients of x. Remember, I talked about this right before I released you. The whole idea is that I need to go from, how many terms do I have right here? 1.
3.
That's 3 terms. One in the middle. But that's 3 terms. And I need to get it to how many terms?
4. 4.
12.
So, right, what you're talking about is these 2 right here. I'm taking this 1 term here, making it 2, but how many total terms do I have? 4. You see that? So you're saying the same thing, we just want to see where those things are connecting, right? We're taking that 1bx and making it 2 terms, giving us a total of 4 terms. If you do not rewrite that bx using those 2 factors, then you're not going to be able to continue. That's it, though. You have to do that. Once you do that, what does step 4 say? Factor the GCF out of the first 2. What's going on? I asked you to wait. Hey, Sean, I didn't even wait on you then. Like, they said more than I did.
Dude, that happened like 20 minutes ago.
So, look. Okay, focus. So, factor the GCF out of the first 2 terms. When I look at x squared plus 3x, a factor is something that's being multiplied. What is a factor that's being multiplied in both x squared and 3x? An x. And when I factor out one of these x's, I am left with 1x. And when I factor out this x, I am left with plus 3. What is a common factor that could be multiplied in both negative 5x and negative 15? Negative 5. When I factor that out, negative 5 divided by negative 5 is 1, so I'm left with 1x. Negative 15 divided by that negative 5 is a positive 3. Notice what key word do I keep identifying or using to talk about factoring out? What did I just say? Negative 15 divided by negative 5. When you are factoring out, you are dividing. So you want to find what can I divide out of both of these numbers. That's it. What can I divide out of negative 5x and negative 15? It's a negative 5. And that's because, notice if I were to distribute it back in, what is negative 5 times x?
How you breathing?
5x. Negative 5x.
Like a fat person.
What is, this is your last warning, otherwise you're stepping across the hall. Negative 5 times 3 is? Negative 15. Okay? All that we're doing with that factoring is undoing my distribution. We're dividing stuff out. Now we're already done with step 4. Step 5, factor out the common. Nope, what does 5 say? Binomial factor. What's a binomial?
2 terms.
That's 2 terms. What's a factor?
It's a number.
It's a thing that we are multiplying by. It doesn't even have to be a number, it can have variables. So what is a binomial factor in both of these? X is
Wait, no,
just,
x plus 3. X plus 3.
that's a binomial, right? Is it being multiplied?
Yes, by x.
There's a binomial. Is it the same one? Is it a factor being multiplied?
Yes.
So I'm going to factor that out. I factor out my x plus 3. And now this isn't getting canceled out. This is just helping me focus my attention. If I have factored out x plus 3, what am I left with? X. If I have factored out this x plus 3, what am I left with? There's my factored form.
Okay, we get up to the next problem.
That's exactly what I did this morning.
We're
about to do another one. Okay. Now, pause, and I need y'all to notice 2 details. This group right here, listen, this group right here set that equation equal to 0. Y'all set it equal to 0. Was there an equal 0 at the beginning here?
Definitely not.
Guys, you can't just magically put in an equal 0. You can't do that. I just asked you to factor the expression, and that was it. Now, the next problem here, notice 1.5, you see how that's still x squared minus 2x minus 15?
Yeah.
That one is set equal to 0. Notice I am also asking you to solve.
CPP.
So we're going to try to use that zero product property, but that means I need what form? Factored form. We just did all of it.
Vertex.
What is the factored form of this standard form?
It is that.
X plus 3. I'm at parentheses, x plus 3, parentheses, x minus 5, parentheses.
So all of this work right here was just to factor.
Good.
Now my factored form equals 0, so I can use the zero product property,
So we know one of them gonna be equal to 0.
at least one of them. So we're going to set, well, notice, saying one of them equals 0 means that one is equal to 0 and the other one's not. But could they both equal 0? That's why I say at least one. Does that language difference make sense?
Yeah, but I said it. I don't know if you heard me, but I said it.
Okay. X equals negative 3 and x equals 5. So you need to pay attention to, am I asking you to solve an equation, so you need a factor first, or am I just asking you to factor?
You're asking us to solve the equation.
For this one. But originally I just asked you to factor. So let's do another factoring problem. I do want to point this out. The one that you just got into your calculator, what's a little bit different about this standard form?
I ain't getting nothing on my calculator.
Well, look up
I
here.
just got it now.
You can't see it. It should have just popped up. What is different about this one though?
It's got thing in front of the X.
So it means you have an A other than 1. This is why I teach you one method. Most of the time when teachers teach factoring, they teach you multiple methods. One for when A equals 1 and another when A does not equal 1. This AC method will always work. Nothing changes from these steps.
Okay, bet.
So let's get up, let's go to our vertical surfaces, let's get this going.
We ain't put out probably.
That's okay. I saw you. Or I saw.
That camera been recording me though.
Let's get this. Let's get this. Let's get this.
Not right now.
Hey.
No, listen first. So write the equation and get other factor. You guys don't forget, talk out the ideas. Talk with each other. To ask questions if you're not sure what's happening. Let's get our equations up. Let's get started. Hey John, let's not plug that in right there where we're trying to work. If you want to plug it in behind my desk or something, that's fine, but yeah. So I do want to point this out. Please note, this AC method, right, all I'm doing is splitting up my middle terms, right, into, or that middle term into two. Positive 7x getting negative 5x plus 12x. We were most of the way right here with this group. We didn't need to distribute it back. That was just to check ourselves. We now have x times 3x minus 5 plus 4 times 3x minus 5. This is at step 5 right here. What's the only thing we still have to do at this point?
Factor.
Factor what out?
3x.
Oh, snap.
They both have a what? 3x minus 5, right? That's what you're saying, right? So I'm going to factor out my 3x minus 5.
Right.
When I factor that out, what am I left with?
X.
X plus 4. There's my factored form. So the last thing that I want to point out is this. If you were asked to solve this equation, you can't solve it right now. Why? Because it's in standard form. But if I can rewrite it into factored form, which we just did that, right? 3x squared plus 12x minus 5x minus 20 equals 0. They both have a 3x. I factor that out, which I think is actually backwards from what we just saw. But factor out the minus 5 here times x plus 4. They both have an x plus 4. Hold on 1 second. Now, notice this is exactly what y'all did. I might have done it backwards in the middle here, but it comes out to be the same factored form. Because I have a factored form equal to 0, what property can I use? 0 product property.
GPP.
X plus 4 equals 0. And 3x minus 5 is equal to
0.
Can you easily solve those equations? Yes. So we just need to know how to go from standard form to factored form. So you can go to enrichment. If you have any questions, now is a great time to ask those questions. Yes. So Quan asked to go first, and Petway, you asked.
I gonna say my
I will.
I'm gonna say my teeth.
You need to take a test. Who else asked me to go to the bathroom?
Me.
Do you have a pass for Miss Morrison? Then you need to go get a pass for Miss Morrison and confirm that you can go to the test. But you need to come back with it before I let you go. Look at what stuff, yes.
I think my life would be much better.
Let me put some on your